worksheet. What is the density of the generic cola? Well, I determined earlier it was 1.084 grams per milliliters. How many milliliters, grams, kilograms, and moles of water are you using? Well, it said use 10 milliliters of distilled water, so it's 10 milliliters. And let's see, and we have 10 grams of water, because the density is 1. We have 0.01 kilograms of water. And now we have to see, well, how many moles do we have? Well, water is H2O, so it has a formula mass of 1 plus 1 plus 16, so we divide 10 grams by 18 grams for the formula mass, and we come up with 0.556 rounded moles of water that we're using. How many grams of sucrose are in solution? Now we just determined that, 2.6 grams. Determine the formula mass for sucrose. It's carbon 12, C12, H22, O11. So it's 12 times 12.01 for carbon. And again, I do that on the side here on my calculator. Plus 22 times 1.01 plus 11 times 16.00, and I come up with a formula mass of 342.3 AMU, atomic mass units. Respectively, 1 mole would have 342.3 grams. In this case, I used 4 significant figures because the atomic mass units on the periodic table are to 4 significant figures, but we'll take them down in a moment to 3 and 2. Determine how many moles of sucrose I used. Well, I take 2.6 grams, divide by 342.3 AMU, and I come up with 0.0076 moles. Notice I'm down to 2 significant figures, simply because I measured to 1/10 of a gram. 2.6 grams, that's 2 significant figures. Determine the total mass of the solution. Well, that's 12.6 grams. The total volume of the solution, well, that's 11.631 milliliters. Both of these numbers were read of in iridium and in liters, so I'm going to write 0.116 liters. I probably don't need that many significant figures. Oops, it should be 0.0116 liters. The total of number of moles of the solution, well, that's adding the number of moles for water and the number of moles for sucrose. So 0.556 plus 0.0076, probably leave 3 significant figures, and I come up with 0.564 moles. Mass percent. So now I have to calculate the mass percent, which goes mass of solute divided by mass of solution. The mass of the solute, which is sucrose, 2.6 grams, divided by the mass of the solution, which is 12.6 grams. Comes out to 0.206, which of course is 20.6 or rounded maybe to integer percent, 21%. Molarity. Molarity of moles of solute divided by liters of solution. Moles of solute is 0.0076 divided by the liters of solution is 0.0116 liters. I come up with 0.655 for the molarity. Respectively, I think I'm down to two significant figures, so let's make it 0.66 molarity. The molality which is probably not in the book, but it says moles solute divided by kilograms of the solvent, so I take moles solute, which is 0.0076 moles of the sucrose, divide by the mass of the water that was used because it's a solvent, so divide by 0.01 kilograms. Comes out to 0.76 moles per kilogram. The mole fraction, perhaps also not in the book, moles solute divided by moles solution. So moles solute is 0.0076 of the sucrose divided by the moles of the solution, which is a total of 0.564, and that comes out to a fraction of 0.013. No units on this one because moles were divided by moles. The density, well, that's what we determined in iridium. It was 1.083 grams per milliliters, which had matched the generic colors anyway. With results from the Coca-Cola, which you're going to do, you will see that all of these mass percent, molarity, and so on are quite a bit higher than the one for generic cola, and you'll see that, of course, the Coca-Cola contains more sugar, as shown by comparing the various concentrations. So, of course, Coca-Cola does as shown by the various concentrations, as shown by comparing the various concentrations. And that concludes my example of this part of Lab G.